Hi, I'm Umang Verma, and today I'll talk to you about mitigating bias in enterprise AI systems. In my day job, I lead a team of cloud architects for Oracle for APAC. I'm also an independent speaker and blogger on emerging tech and Gen AI. I'm doing this session in my personal capacity, and therefore the views expressed here are my own and not necessarily reflective of my organization. Now, how big an issue is bias in AI systems? As you can see, some medical AI models have not been successful in predicting skin cancer in non-Caucasian skin types. There have been biases in recruitment. Even in law enforcement, wrongful arrests have been made based on biased AI algorithms. So let's understand AI biases in some more detail. There are three kinds of biases in large enterprises. There are algorithmic biases, data collection biases, and modeling biases. Now, algorithmic biases are biases in the AI algorithm itself. They're often reflective of the developer biases of the developers who've built them. So for example, studies have shown that in some developing countries, people with a lower socioeconomic status have a much better loan repayment record than wealthier people. Now, credit scoring models trained on data in developed countries might disregard these nuances, and it might actually be biased against people from lower socioeconomic status, right? But imagine if you were to deploy these models in developing countries, the output would not be great. Another example is hiring algorithms, right? A model trained on historical hiring data could perpetuate gender or racial biases. The past data itself is biased. Now, this leads to a company's brand being affected and ethical concerns being raised against its products and services. The other kind of bias is data collection bias, right? So, for example, in customer segmentation, a retailer that collects data primarily from urban areas might develop marketing strategies that exclude rural customers. Or in healthcare AI, a medical algorithm trained on data from predominantly Caucasian populations might be less accurate in diagnosing conditions for patients of other ethnicities. Now, the third kind of bias is modeling bias. This often arises from limitations of the model itself, independent of data quality or algorithmic flows. This could be due to overfitting of the model on the training data, leading to biased predictions, especially for minority groups or outlier cases. Or it could be the feature engineering itself, right? For instance, a model predicting loan default might exclude important socioeconomic factors, leading to discriminatory outcomes. So if certain features are excluded or poorly represented, the model may produce biased results, right? So what can enterprises do to handle bias? Enterprises can do three things. Okay. Transparency, which means explain the model's decision-making process. Explainability, which means explain, for example, if the model gives you a recommendation, any SOP related recommendation should not come from Wikipedia, for example, but are grounded in reality, and the model can cite the source of that policy. Third is human in the loop. So AI will not initiate action, but it will only offer a recommendation to a human who then takes an action. Now, one of the most effective ways of doing that in organization is using retrieval augmented generation or RAG. What is RAG? RAG ensures that the AI system only looks at your enterprise data to answer any questions. It will not source your query response from the internet or external unverified sources. It will only look at your internal sources, be it your core banking, your service systems, your ERP, your CRM, and your other enterprise systems. So the answer will be given only from your own enterprise systems, which can be cited as a source, which is trusted and verified, rather than looking at the World Wide Web for answers to your queries. What are the benefits? Some of the benefits are that it gives you citations for better explainability. It can ground your answers in enterprise data for improved auditing to surface any biases and eliminate them. So if you see any biases, you can then explore the root cause and understand where those biases come from and eliminate them. It updates the data used by the model to become more representative. It also allows you to extend foundational models, eliminating any latent bias there in those models. So in conclusion, enterprises can eliminate bias by using RAG-based systems, putting in proper model auditing processes, and by constantly evaluating the model training data for any biases. This can help drive successful AI adoption in large enterprises. Thank you for your time, and feel free to connect with me on LinkedIn for any follow-up discussions. Thank you.